So all you math nerds, today we got another math problem. How many arithmetic series are there in the interval 1 to 100? So what does this mean? Okay, let's first say what's an arithmetic series? An arithmetic series is a series where the difference, sorry, yeah, also we need this. I forgot. Uh, for long. So, sorry, how many arithmetic series which have 4 numbers in them are there in the interval 1 to 100? So, an arithmetic series is a series where the difference between each element is constant, meaning that, for example, 1, 2, 3, 4 is an arithmetic series, and also 2, 4, 6, 8 is also an arithmetic series, because the difference here between all of them is just 1, and here the difference between all of them is 2. So yeah, get the point. So now, how and since we can do this up to 100, the biggest arithmetic series one could compose is 97, 98, 99, and 100. So, okay, let's just start by describing this series. Okay, so we want the difference to be constant, and we'll call that difference, say, b, and our starting point, a. So we know that an arithmetic series is always on the form a plus b, and the next one will be a plus b, so a plus 2b, and then the last one will be a plus 3b. Okay, so and obviously b and a and b are integers, natural integers. Um, yeah, we can say more about them, but that's all for now. So this is our smallest one, and this is our biggest one. Okay, we know that all of them are within the interval 1 to 100. Okay, so we can say that we'll just use the extremities, and then we have, okay, so 1 is less than or equal to a, which is less than or equal to 100. And we also know that 1 is less than or equal to a plus 3b, which is less than or equal to 100. Okay, so if a, the smallest possible a, is 1, then we can say that 3b is always less than or equal to 99, which is equivalent to saying that b is always less than or equal to 33. Which, how do we do this? Well, we can start by looking at, okay, what limitations do we have? So we want b and a to be integers. So let's start from the top. We can stay here. Okay, so that's the biggest one we can make. Uh, okay, so we'll just move down. Okay, instead we have 96,
97, 98, 99.
So, okay, here it's quite obvious that you can't use 2 as a constant difference or a jump or a step, or you could say, because then you'd be way off. And the same is true for 95, but at 94 we actually get 2 options. Here we can either go with the 1 step, which eventually takes us to 97, or we can take the 2 step, which takes us all the way up to 100. So if just counting from the top, so far we have, okay, we have 1, 2, 3, and then 4, 5. So here you can see it splits. And then the question is, when does it split again? Because one might expect that, okay, 93 will be the same thing. So we can obviously use step 1 and 2, but we can't yet use step 3 because that would end up at 102. So, and then 100, if we start at 92, we can still not use step 3, but at 91, we can use step 3. So 91 has there are three arithmetic series starting from 91. So what do we have here? Okay, so let's think of it this way. Let's construct a function, capital B, of A that we wanted to denote how many possible arithmetic series we can create from that starting point A. So, okay, how do we think about this? We have 97. So yeah, by the way, we can change that out also. We know that A is less than or equal to 97. Okay, so 97 gave 1. Yes, exactly. 97 gave 1. Anything bigger than 97 gives 0. As in 97, 96, and 95 gave the same thing, although they gave 1. And then 94, 93, 92 all gave 2, and then so on. Okay, so we get quantas of 3 or patterns of 3 where they all give the same value. So we can guess that this is not a, well, maybe continuous function, but definitely not differentiable. Or maybe you can make up some grid function for, okay, yeah, sorry, unnecessary side note. So what should this function be? Well, actually, what is this really saying? Okay, it's saying that the difference from 100 to 94 is big enough to fit 3 2's. So, okay, firstly, we have the difference I just said. Okay, the difference between 100 and 94 in this case, this is just A. So we have, okay, 100 minus A. Okay, we're supposed to do something with this. And since our biggest term is, well, it's plus 3b, what should we use here? Well, we should use, well, we're dividing by 3. That's because, okay, so we have 100 minus 94, that's 6, and then we're dividing it by 3 to see if we're like eligible for 2-sized steps. But okay, herein lies the crux. So what do we have to add to this to make it the same for all? Because if we just have this, then 97 would actually yield 33. So, sorry, we just yield 1. This is 1 which works. But 96, that would yield like 1.3, which we can't use that. So what do we have to do here? We have to add a floor to all of this. The greatest least integer function. So, okay, so this is quite useful. So what we're saying here is that, okay, this is the amount of possible arithmetic series that we can make from a starting point A. And this, if you look at, if you think about it this way instead, so we want the max, or the biggest one, to be equal to 100. This is almost solving for b. This is basically the same thing. And since we just want b to be integer, we use the floor function. Yeah, because you take minus a and then divide by 3. It's basically the same thing. Okay, so this is our function. So yeah, I'll just have to erase some things and then I'll be back. So what do we have to do now? Well, we just have to sum all of them up for every a possible. So uh, the answer we get is when a goes from 1 to, well, we could write 100 here because it would yield the same thing. Because it would just mean, okay, zeros, the first three terms of the last three terms would just be 0. But we can might as well just put a 97 over here. No, I'll put a 100. I'll put a 100. And then of b of a. And then we know that that's that. So what is this equal to? Well, we can just start by writing it out, and I think it will make more sense. Okay, so the first one is minus 1. 100 minus 1, that is 99, divided by 3, that's 33. And then after that, it becomes 32.66666 and 2/3. And then the floor function makes it 32. So we have 32, and then we get a 32.3 continuing. And the floor function makes it 32. And then after that, we actually get 32. And then the pattern repeats. So then we have 31 and 2/3, which just makes it 31. And then 31, and then we actually get 31. And this continues all the way down to 0. And 3 zeros, of course. So what is this? We can rewrite this. I'll jump over here. So, okay, the 33 is alone, but all the other ones we have triples of. So we can say it's, okay, 3 times, and we have everything up to 32. So it's 3 times the sum of dummy variable k going from 0 or 1, it doesn't matter, up to 32 of just k. And this is equal to 33 plus 3 times, if you know the arithmetic formula, what words me, 33 times 32 over 2. And what is this? Well, this is, okay, so we know that this thing here, that's 3 times 33 times 16. So we can extract a 33 from this. I'll continue over here. So we have a 33 times 1 plus 3 times 16, which is 48. So this thing is 49, and then it's 33 times 49. And what the fuck is 33 times 49? I have no idea. I think it's 1,467. That is my guess. Yes, it looks good. Yeah, I think it does. So yeah, this is our answer. We can create 1,467 arithmetic series in the interval 1 to 100. Quite a lot. So, well, yeah, that was big. That was it. All for me. So sorry for this video got a bit long, but I hope you appreciate the problem. It's I think it's very fun, but it's somewhat hard to understand. Maybe I'm not the best at explaining it, but so yeah, that was all for me. Thank you for watching. Make sure to hit the bell and subscribe and like and everything. So yeah, bye bye.